Students, today we are reviewing the second half of our trig unit, which was the law of sines and the law of cosines. So this is a lot to get into one video, and I know that if the video is too long, you're going to tune me out. And so I'm going to try to keep this really short and then just hope that you practice a bit. So we're going to start with the law of sines. And the law of sines you can use for non-right triangles, which is cool because SOHCAHTOA is only right triangles. So it's non-right triangles. It also, by the way, works for right triangles. And it can be used when you have angle, angle, side information, angle, side, angle, or side, side angle, okay? So this one, though, we call the ambiguous case. So less reliable here. I won't give you one like that on the test. So I'm just going to write down what the law of sines is. It is basically that the sine of angle A over the side length of side A equals sine B over side B, which equals sine of angle C over side C. And that's for any triangle. And what's really important about the law of sines and the law of cosines is that this angle is across from this side. That's why we use the same letter. This angle is across from this side. This angle is across from this side. So if we label the triangle ABC, then side A would be this side over here. Side B would be over here. And side C would be here. Okay? We are going to do just two quick examples. So example one, let's draw a quick triangle like that. We're going to say this is 35 degrees. This is 38 degrees. This side length is 15 and this side length is x. Now, if you feel like you remember back from more than a month ago now, the law of sines, I would love for you to try this on your own and then come back to see if you got it right. If, like me, you would have trouble remembering something that you learned over a month ago, just watch the video. But if at any point you feel like you can move forward on your own, you should do that because you'll get a lot more out of these notes if you do that. Okay. First step is to look for an angle and a side that are across from each other where we know both pieces of information. So what I mean by that is that even though I know this angle, I don't know the side across from it. I'm really looking to set up a ratio where I can put values both in the top and in the bottom. And so I'm going to do that with this angle and this side. Okay, they're across from each other, and so I can set up a ratio. So I'm going to say the sine of 38 degrees, so I'm calling this angle A, but it doesn't really matter, over the side across from it, which is 15, equals. Now I've got one other angle that I know. Oh, I wrote that wrong. I'm glad I caught that. Okay, equals the sine of this angle, sine of 38, over the side across from it, which I don't know, and so I use x, okay? Angle, side across from it, equals sine of this angle across from it. Okay, now we solve this using proportions. So the way we do this is we cross multiply. So we multiply those two items together, and when I do that, it's going to be 15 times the sine of 38 degrees. Now that has to equal the other cross product. So when I cross this way, that's this times this, or x times the sine of 35 degrees. And because this is a proportion, the cross products have to equal each other, and that's why I get to put an equal sign there. At this point, you could start typing stuff into the calculator, but I like to wait till the end so I don't have to round over and over again. Our goal, remember, is to get x by itself. And the way we get rid of something that's being multiplied by x is we divide by whatever that is. This is just a number. If I want x alone, I'm going to divide on both sides by the sine of 35 degrees because the sine of 35 degrees divided by itself cancels. And I'll be left just with x. And I can do that as long as I do it on both sides of the equal sign. So divide by the sine of 35 degrees over here. All I have to do now is type this big mess into the calculator. So I'm going to grab my calculator and I'm going to type 15 times the sine of 38 degrees. Don't forget to close off your parentheses. I'm actually going to hit enter so I don't get myself messed up, and then I'm going to divide that by the sine of 35 degrees. So x is approximately equal to 16.1. In example 2, I goofed the first time I tried it, and so I'm starting over, so that's why the video jumped there. But for example 2, please draw the following triangle. All right, there we go. So if you feel confident trying to solve this one on your own, I would love for you to give it a shot. If you don't, just stick with me. So in this case, what we know, the information we have two sides and a non-included angle. And so that's this side-side angle one, which can be a little bit tricky. That's what I called the ambiguous case, but I'm only going to give you ones like that work out okay. So don't stress. For this problem, we're looking for an angle and a side that are across from each other. So I'm going to begin here. The sine of 31 degrees over its opposite side is equal to, and now I'm going to do these two, the sine of x degrees over its opposite side. And so from here we cross multiply. 15 times the sine of 31 equals 14 times the sine of x. And if I'm going too fast, just pause, let your brain catch up, and then press play again. Here's my variable. So I've got two things I have to get rid of here. I have to get rid of the times 14, and I have to get rid of the sine function. The first step is to get rid of the 14, and so I'm going to do that by dividing on both sides by 14. And at this point, I think I'll go ahead and type this into the calculator. So I have 15 times the sine of 31, and then I divide that by 14, and it's going to be messy, but that's okay. So I have about 0.55 equals the sine of x. And if you recall from last week, if we have to get rid of a sine function, we use the inverse sine function. This and this cancel, so I'll be left with just x. So all I have to do now is get this into my calculator. So I'm going to hit inverse sine, and then I'm just going to plug in this answer here so that I don't have to worry about rounding it. And I get that x is approximately equal to 33 degrees.